Good afternoon again, students. This is lesson 2.8, so let's get ready. Let me share my screen with you. All right. Lesson 2.8 is on proportions and similarity. So let's continue. Sorry, my camera's giving me problems. Okay. If proportions are two numbers with the same ratio, then similarity is the fact that two figures have the same ratio. Okay, so let me kind of explain what I mean by that. So in lesson 2.8, it's talking about similar figures. Now remember, proportions are ratios dealing strictly with numbers. Now the numbers may represent things like the ratio of the length of something to the height of it. Okay, but when we talk about similarity, we're not just talking about numbers, we're talking about the actual figures or things themselves. Okay, so where a proportion may be talking about numbers that can represent anything, similarity is talking about numbers that represent the length, the width, or the sides of shapes, actual shapes. So these pictures are roughly drawn from page 143 in your textbook. You can take a look at the page yourself and look at their figures. But anyways, so I have two triangles here. Now these two triangles have the exact same shape, but they have different sizes. The one circled in yellow here happens to be smaller, and the one circled in green happens to be larger. Okay? When they have the exact same shape but different size, we call that similar. Same shape, different size. Now the symbol for a similar figure is this little thing. It kind of looks like an accent mark. But instead of equals, you would put that to say that two figures are similar in between them. So therefore, I have this statement. If triangle ABC is similar to triangle FGH, then they are proportionate, which means that they have proportionate sides. Okay? So here's ABC, and here's FGH. So they're proportionate, meaning that they have the same exact angles, but they have different sizes, or that their sides have different lengths. Now, as you can see, I've put a definition for congruent, which means same shape and same size. And the congruent symbol looks like this, sort of like the accent mark over an equal sign. But that means that you have two things that are exactly alike. That's all that means. So if I had two triangles that are congruent, they're the exact same shape and the exact same size. Now, given this talk, I want to go into a little bit more detail about similar. Now, I wrote a little hint here. If figures are similar, the angles are exactly the same. For example, if this angle was like 58 degrees, here angle G, then angle B here would also be 58 degrees. Okay? And the reason I say that is because by the degrees of the angles don't change. It's just that the figure itself just happens to get wider or larger when it's made as a new similar figure. Now I want to show you the steps of using proportions to solve. Now you might have noticed this, or you might not have, but I didn't give you the long side here of this triangle. This FGH, the side that's known as GH, the side value is missing. Now the other ones are there. This is 12 units, 15 units. And if you go back to this one, I have the value of the corresponding side. BC here is 12. It corresponds to GH, which is, well, unknown. So I have side AB is 8, side FG is 12. Side AC is 10, side FH is 15, and side BC is 12, but side GH is unknown. So let's figure out how we can find this out. Okay, step one, pick two similar sides from each figure. Now moving this back here, um, I can pick side AB and FG. Those two are similar. I could also do AC with FH, but I'm going to go ahead and do the first one that I mentioned because that's what I wrote down and I'm ready to teach you with. So side AB, as you can see here, is 8. So I went ahead and I put 8 as part of my proportion here. Side FG is 12. Now, you'll notice that 12, or the side FG corresponds to side AB. I keep on I'm trying to move this so that you can see everything at the same time here. Okay, just move that down a little bit. A little bit more. There we go. Okay, so I'm going to put those two sides as the numerators in my proportion here. Okay, so step 2 is write as a proportion including the missing side. So now my missing side is a question mark, so I'm just going to use x because x is a good number to use when you don't know what the number is. But what side corresponds to GH? Aaliyah, you're right. It is side BC. As you can see, that side is basically like the same side, but on a different figure here. Okay, so BC is equal to 12. So the stuff from my smaller triangle I'm putting here on one side, and then GH, we're going to call it X because we don't know what that side is for the bigger triangle. Now, you notice that when I made a proportion, I used small and big, small and big. Here's the numbers that represent two sides of my smaller triangle. Here's the numbers that represent two sides of my bigger triangle. However, the missing side is called X to represent the one that we don't know. So let's go ahead and we will cross multiply. 8 times X is, yes, 8X, that is correct. 12 times 12 is 144. Okay, so 8X equals 144. So we're going to divide both sides by 8. Let's do the easy part first. 8 divided by 8 is 1, and 1 times X is X. Now the harder part, I have 144 divided by 8. Well, that's not terribly hard, but I'm just going to show you that it is okay to use a calculator to do some of the arithmetic. Okay, 144 divided by 8 equals 18. Very good. So the missing side, X, is 18. There's our solution. Now I'm going to take the solution, go back up here to the triangle, and write 18. So side GH equals 18. Okay, let's see how we can do that. All right, thank you very much for your time.